Good day. This lesson is primarily about carboxylic acids and it'll lead into esters, but before we do that, we need to tell you more about functional groups than you ever wanted to know. So we started this whole unit talking about just chains of carbon atoms, and that gives you pretty generic alkanes or alkenes or alkynes depending on the bonding. And you've seen in previous lessons that you can attach a OH, which we call a hydroxyl group, onto a carbon chain, and that fundamentally changes its properties. So we already know there is one functional group, OH, which if you're used to inorganic chemistry, you probably want to call a hydroxide ion, but in organic chemistry it is called a hydroxyl group, because they have to be different in every way. Now we have to talk about a couple other functional groups, and the names are going to overlap. I'm sorry for that, but that's how they work. First of all, if you have a carbon and you attach a double bonded oxygen to it, like so. This carbon has 4 bonds on it, so it is possible to have that carbon connected to a carbon on one side, something on the other side, and still be holding a double bonded oxygen. That connection, just the double bonded O, or sorry, I should say a carbon with a double bonded oxygen on it, like that, is called a carbonyl group. Now, if you have a carbonyl group with carbon chains on either side of it, that produces a ketone, which we do not cover in our course. They're not far away, and they're not hard to brush up on if you ever need them. They have names like methyl-methyl ketone or methyl-propyl ketone, depending on what the chains on either side are. But for now, I just want you to know the name carbonyl group, because you might see that when we're talking about these acids in a bit. So the double bonded O makes it a carbonyl group. I had one professor who called it a carbonyl group, but he was British and their English skills are suspect, so I'm going to go with carbonyl group, and I hope there won't be too much trouble with that. Now, just a slight variation on that, if you have that carbon with the double bonded oxygen and then another oxygen, this structure, where there are 2 oxygens and one is double bonded, one's single bonded, is called a carboxylate. And typically there will be a bunch more carbons connected to this, and on the other side there can be, well, a variety of things. More about that in a moment. So a carbonyl group is just the oxygen, carboxylate is 2 oxygens, and the last one, the one that we really need for this unit, is if you have a carboxylate and you attach a hydrogen to it. So if you have C, double bonded O, single bonded O, and then an H, now you have almost the same name, a carboxyl group. And you will see a lot of chemical compounds like, let's see, ethanoic acid, I believe vitamin C, ascorbic acid is another one, that end with COOH. They'll write things like C3H7COOH. Anytime you see COOH, they are talking about a carboxyl group, and it's going to be arranged this way. So, this was important when we were talking about alcohols. Carbonyl group and carboxylate, I'm not going to say quite so much in this lesson, but we are going to talk about carboxyl groups a whole bunch, because if you have a carboxyl group on you, then you are a special category of compound called a carboxylic acid. And we need to know how to name these. It says here, name the parent alkane that contains the carboxyl group. So we're going to be looking at chains that go carbon, 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 and at the end they have COOH, just like we were talking about. Carbon, double bonded oxygen, single bonded oxygen, and that oxygen has a hydrogen on it. And the names for these are always going to look like something oic acid. And guess what? The name that goes here, just like with alcohols, depends on how long is the carbon chain, how long is the primary. So, in this first example, we have a primary which contains 4 carbons. I know this carbon is part of the carboxyl group. That's okay. It still counts. This is still considered to be a 4-carbon chain, and if it were just 4 carbons, we would call it butane. But I'm leaving the E off to leave room for the ending, which is now oic acid. This compound is butanoic acid. Next one, COOH. Here's our carboxyl group. We have 2 carbons in our primary. 2 carbons is normally ethane. But I'm leaving the E off because I'm not saying ethane, I'm saying ethanoic acid. Vinegar is a mixture of ethanoic acid and water. Only a tiny bit. It's like 5% ethanoic acid and the rest water typically. Okay, what's this next thing? COOH. This only has 1 carbon. This is the simplest of these acids that you can possibly make. 1 carbon, we would typically think methane. But we leave the E off, switch to green, methanoic. Oops. Sorry, my color switch didn't work. Methanoic acid. That one's also known as formic acid. Okay. Sounds a curveball. Our primary in this thing is this molecule, which is, don't say cyclohexane, what is this? Benzene. Now, based on how these other ones have been going, you might think I'm going to say benzenoic acid, but they cut off the name a little sooner than that, and this is something you just have to remember. This is benzoic acid. This is a food additive. If you look on the ingredients, unless you eat really natural food, if you look on the ingredient labels of a few things in your kitchen, you'll find benzoic acid or its relative sodium benzoate as an ingredient. They use it as a preservative. It keeps things from spoiling. Because I know you were dying to know that. Okay, here we have a carboxyl group, and our primary is 5 carbons, which we would ordinarily call pentane. But I'm leaving the E off, and we're going to call it pentanoic acid. But wait, that's not all. In addition to the pentanoic acid, we have a branch here, so we better tell people about that. This branch is a 1 carbon, not methane, a methyl group. So this is methylpentanoic acid, and we have to say what carbon it's on. Now, new thing, when you have a carboxyl group, automatically your numbering starts from where that is. So this is carbon number 1, whether you like it or not. It doesn't matter where the branches are. It doesn't matter if this makes these numbers sky high. You must start counting from here. So this is carbon number 1, 2, 3, and that makes this 3-methylpentanoic acid. Even if the branch were down here and we end up saying 5-methylpentanoic acid, and you're thinking, if only I could start from here, I could call it 1-methylpentanoic acid, you're not allowed to. Carboxyl groups automatically set your numbering to start in the carboxyl group, so we have no choice about this one. It happens in this example no matter which end you count from. This is carbon number 3, so this is maybe not the best example, but know ye that carboxyl groups are automatically number 1. Okay. And here, carboxyl group, this is what they look like in line structure. And that's 1, 2, 3. We could go 4,5 and make that our primary. We could go 4,5 for the primary, or we could go 4,5. Why would we not want this one? What's wrong with that? The trouble with that is then we have a branch with another branch on it, and currently we don't have a good way of naming those. So we want to avoid that, and if we make, let's say, this our primary, 1, 2, 3, 4, 5 carbons, then we can say pentane is our primary, and because of the carboxyl group, it is pentanoic acid. And now we have to talk about branches. We have here an ethyl group that starts with E and a methyl group that starts with M, so we'll do the ethyl group first. It's ethyl, and that is on carbon 1, 2, 3. 3 ethyl, and on the 4th carbon we have a methyl. So 3 ethyl, 4 methyl pentanoic acid. Sorry for the cramped writing, I need to do that better. Three ethyl 4 methyl pentanoic acid. Again, we head to count from this end no matter what it does to our numbering because the carbon in the carboxyl group is always our first. Fair enough.